to start by putting your name, date, and period in the top right corner of the paper. The title of this notes is Vector Operations. And the objective for this notes is to be able to add, subtract, and multiply vectors, both algebraically and graphically. Remember to draw your line down your paper, and the rest of these notes are going to stay on the right side of your paper. We're going to begin by talking about addition. If we have some vector u that's defined as AB and some vector v that's defined as CB, when we're adding the vectors, we're going to add the two horizontal pieces and the two vertical pieces. So we're going to add A and C because they're both along the x-axis, and then we're going to add the two vertical pieces B and D. And that's where we're getting this formula here. U plus V is going to be AC and BD. As an example, you're going to go to page 697 of your text, and you're going to put example 3 into your notes. That's going to be an algebraic example. We're going to do the same problem graphically. So when you're graphing the sum of two vectors, you're going to start with the first vector. So we're going to start by graphing vector u, which has a terminal point at 2, -7. Looking ahead on our graph, we can't graph -7 if we count by ones. So we're going to scale our graph to count by twos. You always want to scale a graph. Once it's scaled, then we can plot 2, -7. So from the origin, we're going to go right to down 7. And we're going to draw that vector. That's vector u. Now, wherever the terminal point of u is, that's where the initial point of v will begin. So at that point, 2, -7, from that point, we're going to go left 3, up 4. So that's going to land us right here. We're going left 3, up 4. And that's going to represent vector v. And then if we connected back to the origin, that would be our sum. And we can see on our graph that our sum goes left 1 and down 3, which is the same solution we had for the sum when we did it algebraically. Notice how we put the tip of u next to the tail of v. So this technique for graphing the sum is called tip to tail. Next, we're going to talk about subtracting. So let's suppose we're going to use the same example. Vector u is AB, vector v is CD. Now, we're going to subtract A minus C, B minus D. We're going to do the same example as before, subtracting. So u was 2, -7. You need to make sure I use the vector symbol. And v is -3, 4. Oh, u is -7. There we go. All right, so now when we subtract them, we're just going to go in order. So to do u minus v, we're going to do 2 minus -3, that's positive 5. And -7 minus 4, that's -11. So the difference, u minus v, is 5, -11. There are two ways to graph 5, -11. In the first graph, we're going to put the two vectors u and v tail to tail. We're going to put the two vectors tail to tail. So thinking ahead, how am I going to scale this? I think going by twos will work again. Be sure to scale that graph. All right, so we're going to put vector u starting at the origin, and we're going to go right to down 7. which means we're going to end about here. So that's vector u. And then we're going to go back to the origin this time for v. So they're going to share their initial point. So v is going to be left 3, up 4. And then we're going to connect the two tips together. And that'll be the difference. And you can see in that blue vector that we just drew, if we wanted to count, it goes right 5 and down 11, which again is how we get the difference. 5, negative 11. There's another way to graph this, and that is tip to tip. So we're going to start with vector u. I'm going to keep the scale consistent. 2, 4, 6. 2, 4, 6. And we're going to start just like we did with putting vector u at 2, negative 7. Okay, now we're going to put v. V is the vector negative 3, positive 4. But we're going to put it so that it points to the same terminal point as u. It moves 3 in the horizontal direction, so I'm going to go over 3. Even though it says negative 3, I'm going to go right, because this thing is actually going to point backwards. And because it says positive 4, I'm going to go down 4. That's going to take me off my graph. So you might need to go a little bit below your graph, and you're going to draw V. So now V, it's still going left 3, right 4. I just had to go backwards because I'm going backwards. I'm plotting the initial point instead of plotting the terminal point. Now when the vectors are tip to tip, you can go from the origin to the other initial point, and again you're going right 5, down 11, which is the exact same difference that we had before. The last operation that we're going to look at is multiplication. We're going to multiply by a scalar. A scalar is just a single number that's not a vector. So it doesn't represent motion. It has no magnitude, it has no direction. We are just going to distribute the scalars. You can see here when you have a number outside of the parentheses, you're just going to distribute it, and you're going to multiply it by the x-coordinate, multiply it by the y-coordinate. And what this is going to do is it's going to stretch or shrink your vector. So in the picture in red, you see vector u. If we were to do 2 times u, that means we want to go twice as far as vector u. So you'll see that in the picture, it's twice as long as vector u. And you can draw the arrowhead for u there. So you can actually see 2 u vectors being added together. You can also have a fractional scalar. So if you see here in the green example, 1/2 u, and you'll notice that 1/2 u is exactly half the length of the original u. You can also have a negative scalar. So in this pink example, we have negative u. Notice that the magnitude doesn't change. All that changes is where the arrowhead is. Instead of being in the top of this vector like it is originally, it moves to be to the bottom. That's what a negative scalar does. This is the end of the vector operations note, so go ahead and draw your line for your summary.